Hi everyone, welcome to my channel. I hope everybody is doing well and safe at home. I'm starting a new video series on Ansible where it will be consisting of a lot of practical labs on Ansible along with the theoretical concepts. After completing this bootcamp, you can say it is a small bootcamp that I am creating, and you guys will be able to play around with Ansible in your day-to-day routine. And trust me, it will also help into your interviews. So having said that, let's start the agenda for today. And don't worry about all the pointers because these are segregated into number of videos. So today's video is totally focused on the conceptual part. We will start with why Ansible before understanding what Ansible is. There's a requirement of understanding why before what, because we were doing well without Ansible. Then what was the requirement of bringing Ansible into our life? Then we'll understand the workflow along with the architecture and the related components. And finally, this lecture will end up with the advantages of Ansible. So let's start why Ansible. Now, let's deep dive into it because this is a big question. So first question come into my mind, if we were doing well without Ansible, with all the manual steps, lot of automation using shell scripting, then why bringing another tool, a config management tool, whether it is Ansible, Chef or Puppet or any other tool, and learn it from scratch? So we will understand this with an example. Think of a scenario where you have been given a task into your environment to install some packages on 50 servers or 100 servers or 500 servers, depend upon how large your environment is. Then what all possible ways are there to achieve this task? One of the way is a manual way, which we most of the guys have started our career with a manual way. So what are the steps required to perform this task in a manual way? So we have to log into each of the 50 servers, 100 servers or 500 servers and start installing the package. First, you have to check whether the package is already installed or not. If not, then you have to install the package, the required package that was given to you. Now, obviously, this is an easy way and we have done this in our past. But think of a scenario or think of how much effort and time that you have put in to complete this task. Let's say one server is completing within 10 minutes, and again depend upon it's an assumption, right? It's not an accurate number. So one server 10 minutes, 50 server 500 minutes, 100 server 1000 minutes, right? Plus minus depend upon the network speed and how fast is your server. So disadvantage for this particular method was a lot of time consuming process. So if I have to complete 50 servers, 100 servers, 500 servers, I have to wait or I have to segregate the task between the shifts. 8 hours of shift, one guy will be performing this much of task, then we have to hand over to the another shift. So if your environment is pretty large, then it takes a lot of days to complete the task. Then to overcome this particular method, what was the second method bring into picture, which is an automation, scripting, shell scripting. So you have to just figure out the logic for one server and then you can loop around the script or loop around the servers which is placed in a server.txt file and start copying the script onto the servers to execute locally on that particular server for all the package installation, right? So in this case, what you have to do, obviously, let's say you are originating the script from the jump box or the bastion host. Then you have listed all 50 or 100 servers into your text file. Then you have to copy that particular installation script on all the servers. Once copy is done, then you have to start installing the environment. So another script. Within the same script, we will be writing the two logic, one for the copy, one for the installation. Copy is done, start the installation. So first you have to wait for first server to complete, then it will go to the second server while doing a loop, and then third and so on. So obviously this is one of the best method as compared to the previous one because we are saving a lot of time effort over here as well. Again, think of how much time and effort you put in to complete this task. Let's say one server drilled down from 10 minutes to 5 minutes. So obviously we have saved around 50% of time while using the scripting method. If you're good at scripting, obviously most of the guys prefer to do shell script, PowerShell, or any kind of scripting, right? To reduce the manual effort. Disadvantage of using this method was sequential approach. Obviously better than the previous one, but still it is sequential. One server has to be waited for the second server, and then third, then so on. So we have to wait for that. The third way, which reduces even more, which brings up the parallel execution around the world of IT, was the config management tool. And it can be Ansible, Chef, Puppet, or any other tool, whichever you like or no, come into picture. Now, I like Ansible most because this is one of the most powerful tool across Chef, Puppet, or any other tool. This works on a push mechanism instead, and agentless as well. It just require an SSH or WinRM connection in terms of Windows to execute your packages on the servers. And Chef and Puppets are like having a pull approach. We will discuss this in detail while doing the comparison as well in terms of Ansible, Chef, and Puppet. But that is in the later section. So these are the three methods that obviously I know how you can do the package installation, what was the disadvantages, advantages, and what are the best tools that we should pick and go with it. So that was the reason of why Ansible was brought into picture. Now, let's understand what Ansible is. So Ansible is just a powerful configuration management and orchestration tool. It is open source. One of the best part, it is an open source, so anybody can use it. Now, in 2015, Red Hat acquired Ansible just to make our life easier for automation and development, and to have the support as well for many IT people. So that's what Ansible is. It's a config management tool. And Ansible is known for a fact that we can provision servers regardless of the data center or any cloud environment. We can do config management. So if you have to tweak some of the configuration, you can do quickly with Ansible. We can do the application deployment as well. So if you have an, let's say, exe, MSI, or any packages has to be deployed as part of your application deployment, we can use Ansible to do that. Orchestration, you can do with Ansible. You can have the automated backups as well. So for example, in terms of VM snapshots, we can write an Ansible playbook where it will take the snapshot of your VM or backup of your VM as per your requirement. Plus patching, you can automate the patching of your systems as well. Another one pointer which I want to go back and let you know, the third way that we figured out over Ansible. So 5 minutes, 50 servers, 250 minutes for the scripting approach, right? And 500 minutes for the manual approach. But Ansible or any configuration management tool, we can do a parallel execution, which means 5 minutes, you can parallelly execute all 50 servers. So even we drill down from 250 minutes to 5 minutes for 50 servers. The same goes with the number of servers, 100,000 or whatever the number is. So that's how powerful Ansible is. Okay. Now let's look at the workflow of Ansible. So Ansible work in kind of a master slave model. Again, it requires a master engine, which is present over here, which is called a management node. We call it as master node. We call it as master engine. So that is required, or management node. And rest of the environment, you don't have to worry about installing an agent. This is an agent-less tool. It works on SSH in terms of the Linux platform, WinRM in terms of the Windows platform. Earlier, obviously, Windows was not supported that much, but now we have that support, which is a best part of making Ansible or using the Ansible as well. And it's a part of having a playbook where you write recipes. Playbooks are basically where you give the instruction to Ansible, hey, I have to install this package. Hey, I have to do the deployment on certain servers, but on certain servers, I have to do the security patch update. And inventory, where all the hosts are getting updated. It can be an IP address, it can be your FQDN as well. So that's basically a workflow. Ansible connects your node and run a small program called Ansible module on the client side. After running the module, it removes them, So you don't have to keep everything on the client side. So when I say client, these hosts are the client, which gets contacted with Ansible master node or the management node. So Ansible modules can reside on any machine and do not require to have any database server or application server. There's not a specific requirement of that. It works on SSH or WinRM connection, as I said, and it's an agentless. That's a simple workflow of Ansible, right? Now, moving ahead, some of the workflow terms that we use, basically, I'm not going to read out all the detail since we have already covered it. So Ansible management node, as I said, these are the master node, which is very crucial for Ansible because the inventory file, the configuration file, the host file, everything is present in the management node. So it uses SSH connection for making the modules to execute on the client node, and it removes once everything is done. Then we have an inventory file where you can define either one server, two server, three server, or you can define in terms of group, like database servers has to be there, then application servers has to be there, or some other servers has to be there as part of the IP address or FQDN. And these are editable files at any time as per your requirement. Then we comes with groups and host. As given above, like default location is HC Ansible host. We will be going to check out all the location while be doing the practical lab. And hosts are just like an INI format. Will we look at the example in next page where the headings are in the brackets as considered as a group name for identifying, like, let's say web servers and the DB servers. So let's look at the example group and host. As I said, we can have an app server, web server group, database servers, and everything. So we define all these, and based upon the recipe that we'll be going to define in playbook, Ansible will start executing all these stuff. Then we have Ansible Vault. So Vault is basically where you are keeping all your protected credentials. So the sensitive data, you can say, it can be username, password, or the important data as well. As an example, if you guys have heard about KeePass, or let's say any password safe, or AWS Secrets Manager, Azure Vault, so those tools or Ansible Vault, all these tools are used for protecting your data, the important data, which is your password, username, important data, transactional data, not the transactional data, I would say. Mostly we use as a username and password. We don't want to, or access key or secret key, because we don't want to have those listed in our configuration file. That is not recommended. Also, Ansible Vault provide a key to decrypt to Ansible while running the Vault encrypted content at runtime. So again, Vault is equal to your encryption of your data, which is username, password, or some important data. Okay. Now these are again, I'm continuing with the terms. Let's say Ansible server, as I said, the master engine, and where your playbooks and everything gets written and get executed on different machines. Then we have modules. Modules is a command or a set of similar commands which is executed on the client side. Clients are basically your host machine where you want to run your installation or deployment, depend upon the task that Ansible perform. Then we have task. Task is a section which consists of a single process to be completed. So what exactly you want to do. Then we have role, way of organizing your task and the related files to be called later by the playbook. So we will be going to define the role and everything in later section while doing the practical lab. So role is, again, think of organizing the task, right? App server has to be performed with the patches. Database server has to be performed with some SQL updates or MySQL updates, something like that. Then fact, the information fetched from the client side from the global variable with gathered facts operations. Inventory, as I said, where you define all your server IP address or FQDN. Then play, it is a execution model of a playbook. Handler, this is kind of a task which called only if notifier is present. Then what is notifier? The section attributed to a task which calls the handler if the output is changed. Kind of a notification module, you can say. And tag, obviously the name set to task that can be used later on to the issues that are specific task or a group of job. Sorry. So all these terms consist of an architectural part of Ansible. How? Let's look at that. So this is an architecture of Ansible where we have an orchestration engine consisting of inventory. As I said, inventory where you list out all your hosts with the help of IP address or FQDN, and you can group them as well. Then we have an module. So modules again connected to the nodes and spread across the module program. Ansible also execute these modules and remove after work is finished. Then we have an APIs. These are the transport layer kind of stuff, interact with your public and private cloud. It can be data center, it can be your cloud environment. Then we have our plugins. Now plugins can be like, you can use the core functionality of Ansible. You can write your own plugin as well, right? Then we have playbooks. It consists of a play because playbooks are very important as part of the Ansible architecture. That's where you write the instruction, what has to be done on the nodes, right? The managed nodes, the host, right? Like installation of package, you want to do the security updates, whatever you want to do, right? So that's what playbook is all about. Then we have host on which you are performing your activity. Then we have something called networking. Ansible used to automate the different networks, and it uses simple and secure, powerful, agentless automation forwarded for your IT operations and development. Then we have a configuration management databases as well, CMDB, which we call it as kind of a repo, which acts as a data warehouse for your IT installations. Obviously, then we have users. So that's in general what Ansible architecture looks like. Now, if I read out the line over here, Ansible orchestration engine interacts with the user who is writing an Ansible playbook to execute the Ansible orchestration and interact along with the services of public and private cloud via APIs, not plugins, and the configuration management databases. Now, if I make it more generic in terms of a layman to understand, this is a generic architecture where you can understand in better model. So we have Ansible master server. You can call it as engine, controller, or master. Again, this is kind of a master slave model where it works on SSH or WinRM connection in terms of Windows. So on the master server, we have inventory file, we have configuration file of Ansible, we consist of playbook, and we run all the ad hoc commands on the master server. Now all these are the server 1, server 2, server 3, server n are the managed nodes. We call it as Ansible managed node, or you can call it as Ansible nodes as well. The connectivity that Ansible master engine is having with the nodes is via SSH in Linux based system, WinRM in Windows based system. So that's a generic architecture, right? So that's how Ansible workflow is all about. The architecture looks like in generic way as well. And finally, we come to the end of this lecture, which is the advantage of Ansible. One of the best advantage is it's open source, very easy to set up, very easy to use, flexible enough to manage your deployment, your config management, interact with your Windows system as well now, Linux based system. Does not require to have an agent install on the managed nodes like on your server where you're trying to perform the activity. More efficient in performing the task and very powerful, less complex to handle the IT workload. And trust me, I have used this for multiple clients. I do recommend Ansible. There are like multiple tools, multiple configuration management tool. We have Chef, we have Puppet, we have Ansible, we have Salt Stack as well. So it depends what kind of situation you are in and what is best suited for your environment. I don't say Chef and Puppet are not good. Chef and Puppet are even two good tools, but that requires agent to be installed on the server, pull mechanism. Whereas Ansible and SaltStack, we don't even require to have agent on the servers or the managed node. For me, Ansible always comes top as compared to Chef or Puppet. I have used Chef and Puppet both, and I like Ansible on top of that. So if you ask me the priority, Ansible, Chef, Puppet. SaltStack, I do have a conceptual knowledge. I don't have a practical knowledge on the SaltStack side, but the concept seems to be remain same as part of the config management tool. So I hope this clears a lot in terms of the conceptual side of Ansible, the workflow, architecture, why we need Ansible, why this was brought into picture, and what Ansible is all about. So as part of this series, I'll see you in next lecture where we'll be performing on how to install Ansible on Linux-based system. So most of my videos are totally dedicated to the Linux-based system. Mostly it will be CentOS. Okay. Rest of the steps I will share as part of the description section and as part of my presentation. See you in next lecture. Have a nice day. Bye-bye.